Going back to the original picture, please. We're going to label AD as perpendicular to AC with a right angle. EC is perpendicular to AC with a right angle. We're going to label B as the midpoint of AC with tick marks. And we're going to label that DA, double tick marks, is congruent to EC. Now, the proof itself, I think you all pretty much know what we're going to do. Just in case you don't, we are going to use side angle side in order to get that. And in order to prove that DB is congruent to EB, we are going to use CPCTC, which is corresponding parts of congruent triangles are congruent. Now, to write out this proof, this is what it would look like. I'm pretty sure you guys are all okay with the first part. So, the givens, perpendicular lines intersect to form congruent right angles. B is the midpoint, which is given. AB is congruent to BC. A midpoint cuts a segment into two congruent parts. DA congruent to EC given. And then this second to last step, which is that triangle DAB is congruent to ECB, and we're going to use side angle side. The last step of this proof, which in fact is the most important, is going to have this statement, DB congruent to EB, and the reason is going to be the write-out of CPCTC, and it will look like this. DB is congruent to EB, and corresponding parts of congruent triangles are congruent. So please make sure you get that entire proof written down. If you need to pause the video now, go ahead, and then we're going to move to the second example. So the next part, we're going to the next page now to prove the triangles that contain them are congruent, and then use corresponding parts of congruent triangles are congruent. So please make sure you write that down at some point. The only way to prove sides congruent to sides or angles congruent to angles is to prove the triangles that contain them are congruent, and then use CPCTC. So I'd like you to copy this proof down, please, with these given information and this picture. So let's take a look. Angle A is congruent to angle C. Hopefully you guys can label that correctly. Angle D is congruent to angle E, double swooshes. And B is the midpoint of AC. I'm going to make single tick marks for that. Now, once again, I am trying to prove that in this case, an angle is congruent to an angle. The only way I could do that is using CPCTC, which is corresponding parts of congruent triangles are congruent. And the way that I'm going to prove that is by proving that the triangles themselves are congruent, and I'm going to use angle, angle, side. Think about it. You have an angle, and you have a side. So let's start writing this proof out, please. The first part, I'm pretty sure you all have. A is congruent to C, given. D is congruent to E, given. B is the midpoint, given. AB is congruent to BC. A midpoint cuts a segment into two congruent parts. And then the second to last step here is that triangle DCB, which in essence is the triangle on the right, is congruent to triangle EAB, which is the triangle on the left. Now, when those two triangles are congruent, I can then turn around and say that angle ABE is congruent to CBD, and the reason is because corresponding parts of congruent triangles are congruent. Okay, thanks for watching the video. I'm sure this will take you a little bit longer to write down all the statements and reasons and copy the pictures, but I'll see you in class. Bye-bye.